Exam season is upon us, so let's have a look at a past paper question on enthalpy cycles. What's the enthalpy change for the combustion of hydrazine? Well, we have an equation and we have data, and the data is in the form of enthalpy of formation data. It's a really good exam tip to highlight or underline key information in exam questions as you go. That way you know you're not going to leave out anything important. The first thing we need to do is to draw an enthalpy cycle for this reaction. So we need to figure out what the bottom layer of this enthalpy cycle is going to look like. The data we were given was enthalpy of formation. It's imperative that you know your definitions. So the enthalpy of formation is the formation of 1 mole of a compound from its elements under standard conditions with reactants and products in their standard states. The bottom layer of this enthalpy cycle is going to be the elements that make up either the reactants or the products. So 1 mole of hydrazine is going to require a mole of nitrogen, that's a diatomic gas at room temperature, 2 moles of hydrogen, H2, also a gas, and oxygen is simply oxygen. Note that in order to get the marks, the bottom layer must be balanced and you must include state symbols. The definition also gives us the direction of arrows, forming compounds from their elements. In the next step, we simply add the data to our arrows. So in order to make 1 mole of hydrazine plus 50.6 kilojoules per mole on the left-hand side. On the right-hand side, we're going to need the enthalpy change for making 2 moles of nitrogen dioxide and 2 moles of water. Running from left to right, I simply write each of these enthalpy changes into my calculation at the bottom of the page. If I draw in the alternative route for this reaction, running from hydrazine to nitrogen dioxide and water, I will notice that on the left-hand side, my direction of travel and the arrow for the enthalpy cycle are running in opposite directions. For my alternative route, I don't want to make a mole of hydrazine. Essentially, I want to unmake it. So I need to reverse the sign for the enthalpy change both on the diagram and in my calculation. Then finally, all I have to do is plug this calculation into my calculator exactly as I have written. And I'll come out with the answer, minus 555.8 kilojoules per mole. My final answer can't be more precise than the least precise piece of information that I put into it, so I need to round up to 3 significant figures. If you need more practice with enthalpy cycles and enthalpy calculations, then head over to Crunch Chemistry. We've got everything you need for A-level.